I stumbled across this manual about the Python SDK on the Raspberry Pi site. I've missed it before now because of the crazy way that Firefox and the Mac downloads PDFs when you don't realise. Bit of light bedtime reading. In the appendix here, it's got some information about setting up some various display modules. I've done this before using the PicoExplorer pack and the UF2 file that comes from Pimoroni. On my Pi, I've still got that UF2 file. I think it's at version 9 at the moment. Well, Alpha 9. I was just looking at some of the coding on this and I found this bit here where you can drive one of these 1306 displays with the standard UF2 file that Raspberry Pi ship. If you click on that link there, it takes you to this page to begin with, and you click through on the raw bit and it takes you to here. So I wanted to play about with this, so let's select it all and copy it and paste it into Thunny, just into a blank document on Thunny here. I've been routing through my parts bin and I've found a couple of other OLED displays, so I've put two back to back here. I've just connected the data and the clock signals up in parallel just to see whether it worked, and both screens do, so that was interesting. I was looking at this OLED file here, so this is the one that Raspberry Pi has given us. Let's just save that OLED RPi. I want to see whether I can get it working with this, but I think there's going to be some issues here, so let's just run it. All right, so okay, so first of all, list index is out of range. All right, so there's lots of bits here I've got to fiddle with. On this Pi, I've also got 1306 driver that we installed previously, just saved as a Python file on the Pi Pico. I think the standard build of MicroPython from Raspberry Pi comes with this 1306 driver installed. The pins on here are wrong and it's crashing this index out of range. So let's just comment out those two, see whether that does anything. All right, that gives this OS5 error. I don't like this OS5 error. Whenever this OS5 error runs, nothing else seems to run after it, so you need to do a reset to connect after that. Anyway, let's have a look at the pins first. So 21, data on 20. I'm hoping if I run that, it will get rid of that this index out of range error. Let's just stop it and run again. All right, if you'll get that OS error, as I said, let's just reset this. See whether we can get it to start again. No. Reset it that way, power everything off, start over. All right, okay, so you notice that that error's gone now because I did a reset. So once that OS5 error comes in, I don't know why, don't know what I've done, but it's moved on anyway. So I've got the pins right, and I'm now saying this object has no attribute Blit. We'll come back to that, but let's just have a look at this. Let's put this back in, see whether that works. So just to look through this file, there's the Blit. We know what Blit does, but let's just comment that out for the moment. All right, so we've got something happening, which is good. So we've got Raspberry Pi Pico on the OLED screen. So we've got to fix this Blit, but we see what it's doing. It's got this byte array here. You saw on one of my previous videos, I'd done something similar with an RGB array. But this is a slight different array, I think, because this is just single color, because down here it says, look, this frame buffer is just mono HLSB. Don't know what HLSB stands for. I just think this is on or off. Might be wrong. Don't know. What does that do? A byte array anyway. If we look at what this is doing, it's got the frame buffer up here that we used previously, imported into our code. So this is like my Aliens frame buffer. So a 32, that's a 32 byte array. This is a 32 by 32 frame buffer it's creating. And here it's saying Blit this frame buffer onto the other one. So hopefully it will take a graphic here, which is going to be the Raspberry Pi logo, and put it somewhere on the screen. So let me just go in and see what the error is again. So it's saying this SSD1306 IC2 object has no attribute Blit. this frame buffer here should be, because we've imported it from there, it should have a Blit on it. We have to run the Blit on the screen frame buffer. So if I was to open, this is one of my early bird scripts. So we create a display buffer here and then pass that display buffer into the display driver. On that display buffer we can call Blit, but it's saying that OLED doesn't have a Blit. So what's OLED? OLED is an instance of this SSD1306. So if we go to this bit where we import it, we're importing a SSD1306 I2C version from this version of 1306. So we go and look at that. So it's probably not this bit, although I think it's extending this bit. But if we go through and look at the I2C version, we call it with the width and the height and the address. But here it's creating a frame buffer itself from the height times the width. So it's got its own frame buffer. So if that's self frame buff, can we get at that frame buff? I think we can. We know that this SSD1306 script has its own internal frame buffer. So instead of calling Blit, we want to call the frame buffer and then we want to call the Blit on that. So what was it called? It's just called frame buff. Self frame buff. So can we get to it? Will it let us get to it, or is it somehow private? Frame buff it was called, and then just call the Blit of that. So we're talking directly to that internal frame buffer now. Well, this module's internal frame buffer. So let's just stop that, see whether that works. Okay, object has no attribute frame buff, probably a typo. Right, frame buff with 1F. Excellent. All right, so that's a little graphic that we've managed to get on there. So you see Raspberry Pi Foundation on their little bit of code. They've stored stuff in it in a byte array. They've created this logo. Obviously, this style of byte array takes up less memory than a full RGB byte array. Don't care about this, we're just playing about with this screen. But it's nice that if we know what's in this module, which we can because we've got the Python implementation of it, we can see the fact that it's got a frame buffer, and amazingly we can call that frame buffer outside of that module, talk directly to it, and then that gets us to the Blitter. Now I suppose what we could do, we could modify this and put a method on here which talk directly to the frame buffer itself. But maybe if we did a def there with Blit, then we could pass the external Blit directly into this. But as this is someone else's module, it's useful to see how it works, but not something that I'm going to change today. So that's porting, in a way, this Raspberry Pi OLED code, including the graphics code, which I wanted to have a look at to get this Raspberry Pi logo, pushing it directly onto one of these OLED screens using the UF2 from the PicoExplorer.